Hello, this is section 1.8. This is on solving absolute value equations and inequalities. With this section, it's very similar to the last section that we just did in section 1.7, but the difference is now I'm going to have absolute value. Just to recap or backtrack a little bit, absolute value actually means the distance from zero. So when they give you a problem like this, they're asking you what numbers are 3 away from 0. So for this particular problem, a lot of textbooks write it like this, where they say 2x minus 5 equals 3 and 2x minus 5 equals negative 3. And then they go ahead and solve both problems. Add 5, divide by 2, so x would equal 4. Add 5, divide by 2, and x equals 1. Main thing I wanted you to see with that is that I did the same exact steps for both things there, just so that you are aware of it. Now, a lot of times what people do is that they get a 4 and then they think it's plus or minus 4, and that's not true, because if you put 4 into this problem here or negative 4 into that problem, negative 4 would not equal 3. So just as a self-check, make sure you put both of those answers back in and figure out if they actually do in fact make 3. If they don't make 3, you screwed up. Okay, now another way that you can look at that, what I like to do with this is that I like to make it look like a compound equality. So as long as the absolute value is all by itself, which it is, I take negative 3 and I put it equals 2x minus 5, and then also equals 3. And the reason why I do this is now I'm making it so that it's the same things, the same exact stuff for both, or the same stuff or the same type of mentality for each of those, where I'm going to add 5. And I'm doing the same steps there. Now, the one thing that I'm going to caution you on is that when I get to the final answer, this is what I'm not saying. I'm not saying, it looks like I have 1 equals x and x equals 4. I'm not saying that 1 could equal 4. What I am saying is that those are my two solutions, x equals 4 and x equals 1. That works if as long as you have the absolute value all by itself. It is totally up to you on whichever way you want to do this, whether you write it as 2 separate equations or if you write it as 1. It will work. Now, when I do this next one, it's a little bit misleading because of the fact that a lot of people, what they do is they put equals 14 and negative 14 right away, but that's not entirely true. What you have to do is you have to get this absolute value all by itself first before you can do that. So first thing I need to do is subtract 5. And then divide by 3. Now, once I have the absolute value of it equaling a positive number, by the way, if this was a negative number there, if you would have the absolute value equals a negative, you could stop. Because there's no way an absolute value can equal a negative distance. So be careful with that. That's why you do that first. Do not set it equal to 14 and negative 14 right away, because it will not necessarily work out. Now, if I like to do it the way that I just showed you with my last method, 2 equal signs, because I'm doing the same step, might as well just do it once. So I end up with 4 equals x, which equals 10. Okay, so on that particular thing then, I end up with 4 and 10. Okay. Now, when it comes to inequalities, we're going to actually set it up the same way. X minus 5 is less than 2. When you see this, a lot of times what books do is they give you x minus 5 is less than 2, and then x minus 5 is greater than negative 2. What happens is when you write the opposite of the 2, you also have to write the opposite symbol. And most people forget that. They forget to write the opposite symbol there, and then they end up getting it wrong. Me personally, I like to do it this way. X minus 5 is less than 2, so I wrote the exact same thing. And then I point the arrow the exact same way, and then put the opposite 2 on the other side. Notice my arrows are the same way. That's important because now I've eliminated that self-doubt whether or not I'm supposed to have it facing the other way or anything like that. The arrow should point the same. If you look at the second equation I wrote here and look at this part of the equation there, they are exactly the same. The Pac-Man is eating the X minus 5. So I have the same exact stuff. And I add 5 to everything. I get 3 is less than X, which is less than 7. Then I go to my number line. I would have open circles. Now for this particular thing, there's no need to test a point because we are going from either in between or on the ends. And when it's a less than symbol, you're going in between your 2 dots. Interval notate would look like 3, 7 with both parentheses. The reason why both parentheses is because you have not included. Don't confuse that with ordered pair. Okay. On that particular thing, if it would have said greater than, we would have shaded on the outside ends. Okay. I'll give you another one of those. As long as the absolute value is all by itself, you can start. If it's not, then you move everything to one side versus the other, but it is, so we're good to go. So I have 3x plus 2 is greater than or equal to 4, and negative 4. Subtract 2 to everything. And then divide by 3. Negative 2, x 2/3. Okay. Now for this particular thing, when I go to graph this, my negative 2 is back here and my 2/3 is up here. Now I just put them on the number line like that today instead of doing it a different way. But now I'm going to close those in and it should graph out here on the ends. And if you don't trust that greater than goes in the outs and less than goes in between, you can use the test point method that we did in section 1.7, but that's what would end up happening for that. How do you interval notate that? Negative infinity, because you're going all the way to the left, up to negative 2 with a bracket, then a union symbol because you have a space, bracket 2/3 to infinity. Always work left to right, and that is how that one's going to work. Again, if the absolute value was not by itself, I would have to add or subtract everything over first. Another thing that ends up happening is if you have the absolute value is less than a negative number, that's a false statement. The absolute value of something has gonna be, with the distance from 0, it could either be 0 or it has to be positive. So if you get something that has the absolute value of, it says less than a negative number, that's not true. On the other side of that, if you have the absolute value of something and it says greater than a negative number, that's always true. So my answer could be all real numbers, and that would be perfectly fine with putting that as an answer. Because everything would work, no matter what. The interval notation for all real numbers is negative infinity to positive infinity. Okay? So as far as the inequalities go and absolute value goes, this is really a short piece of this, this stuff here today. So that is it for section 8.